So in this video I'm going to show you how to save a lot of time and a lot of money for your engineering business. And if you're an employee, it will save you a lot of time because you'll be able to hit deadlines a lot easier with a lot less stress, whether you're the engineer or the CAD technician. I need to place lights down on this floor, level 2, and I have this DWG markup, which is basically just lines with specific layers on. So each line is a certain length that the engineer has designed, and he doesn't need to mark up what the spacing is or anything like that. He's already put the spacing down, and he's just given me the type mark by providing it as the same, the layer of the line. And so with that in mind, I'm going to do this floor here, level 2, and I will come to Rhino inside, Rhino player, run level 2, and all of those lights are placed accordingly in the exact location. Now let's just say the engineer had a few changes on, say, level 3. We can see that level 3 is something I completed earlier. Let's just say he wants to rotate these. Let's just say he wants to delete those, and he wants to change these to L03s, the small ones. Yeah, and he doesn't even need to resize these if he doesn't want to. But these have not rotated. Let's just do that. Okay, good. And then hit save. So the original DWG is now saved, and because it's linked, I can reload the latest one. Manage links, CAD formats, reload, say OK, and then come to Grasshopper player. That's level 2, right? Sorry, level 3. There you go, the lights are saved accordingly. You can see these have been resized, that one. These have been deleted and those have been rotated. And so let's just say he's changed his mind again. Surprise, surprise. Let's just undo all of that. He's added them back in, or let's imagine it was a completely new design. I come over to manage and I say manage links, CAD formats, reload, say OK, and then come to Rhino inside, Rhino player, L3, and that's that. There they are. They're back in place in their correct rotation. And we can see they are underneath that floor. That's what this video is going to be all about. I'm going to be showing you how to do that. And you'll be able to place thousands of lights, thousands of elements, even if you're not using this for lighting, thousands of elements within minutes. So stay tuned. And if you've named it what it is, L0, the DWG file, they kind of know how to read the script. Now, I want to zoom into element geometry and click this plus because I want to see not just the geometry but the categories. I can also expand that top one, which we don't need to do today, but it's just for your benefit to show you what it does. I will do that. And I'll put a panel down and I'll show you what each of them does. We only need the bottom two for this one. So this will tell you what the element is, the first one. So it's an imported DWG file. It doesn't actually say it's a DWG file, but it's an imported thing. In this case, it's linked. So I'll copy a panel and I'll show you what's in geometry. In geometry, we have 355 line-like curves. And then in categories, we have, it's not, I'm trying to expand it. We have did I say 355? I meant 353. 353 categories. So what it does is it takes the geometry from the imported file, in this case the DWG, and it splits the file into all of the lines and whatever other element there is in there. We have kept only the lines in this scenario, in this DWG, just so we can use it for this function. That's why we're only seeing lines, because we've deleted everything else. So it will show you every single element in that DWG, and it will tell you what Revit categorizes it as. In this case, it says it's a line L05, a line with the layer L05 in this L0 DWG, and that's its ID. We don't need to worry about the ID for now, because AutoCAD doesn't really have an ID system. So to those that don't know, an ID system is like a unique number given to each element. So when Rhino imports this, or when you import this into Rhino, it kind of gives everything the same ID because there's no ID system. I mean, sorry, there is, but it's not translatable into this. Yeah, there is an ID system in AutoCAD. Just we don't need to worry about that for this one anyway. Now, another thing to understand is all 353 lines in this geometry output correspond exactly to all 353 Revit categories. So line number 353 has the layer name L05. And if we go all the way up to the top, line number 0 has the layer L01. So everything is in order. Everything about this task, or these tasks, is about finding data and keeping it in order, because the computer doesn't understand what things are. It just keeps one set of data in order and another set of data in order. And then when you do things with it, it just does it line by line. So if you wanted the information from layer 1 or line number 1, and you wanted to know what layer it's on, it would find number 1 of the next of the list of layers. Yeah, I really hope I'm not confusing you there. But that's basically how this works. It's all about ordered, structured data. Learn about the order and the structure, and everything else will fall into place. So let's begin. I will start by, oh crap, I don't want that, go away. How do I open that file? There we go. So I will have this final out. This is what the final script will look like. If you want to take a look. And we're just going to be making this section here. We're going to be getting the Revit layer data, and then we're going to be, you know what, I don't think I'll do that in this video. There'll be another part where we query types, because I need to talk about some Revit things in that video. So in this section, we're just going to be getting the layer names from the AutoCAD linked file. So first thing we don't need this elements thing, so I'll just remove it. If we just take a look at what's in here first, what you'll notice is that the layer name is here. All we need is that piece of text in this same order. That's all we're going to do. We're going to get rid of all the other words, all the other letters and numbers and whatever, leaving only that. So we have an ordered set of layer names. We want to know what layer each of these lines is on. So what we'll do is we'll get the text split node. Let me maximize this. And we're going to split this text with this line here, because if we split the text, let me explain that a little bit better. I apologize. If we want to split this text, we need to tell Grasshopper where we want to split the text. And with the text split command, we can give it a separator. So if I say I want to split at every point where you find this symbol, and we plug it in, we will get a result like this. So it's split the text into what's before that line and what's after the line, or symbol in this case. If I was to change that to a colon, we see that there's a colon here and a colon here. Splits it at every colon, including the little space before and after. Yeah. So we're going to keep that as this symbol. I don't know what that's called, to be honest. And we have our text. So I'll keep this here, this original, so we can see what's happening at every stage. And I'll shrink it down a bit. Now, I only want what's in index number 1 for every single element. I don't really care about index number 0. So I say search for list item. Oop. And I plug this text split command output into there. And I want to tell it that I want index number 1 oh no, I need to put number 1. Right, so now let's see what's happened. So we have a tree of L01s, yeah? Now bear in mind, we want the end to have this structure. You see this gray bit? We don't want any of those. I'll show you how to sort that. I'll show you how to do that in a second. We're going to do that right at the end. Now, the next thing I want to do is I want to split again, but after the layer name. In this case, a space is good. So if you've got spaces in your layer name, it will ruin it. That's why we don't really use spaces. In this case, the space is what will sort everything out. I'm going to copy both of these, and I will say this, and I will change this to space, and then I will see what I have. Now, we see that this time I want what's at index 0, which is the layer name. Yeah? So in this index thing, index list item node that I copied, I want to change it to 0. Excellent. So now if I see what's in the output of that, it's all L01. So now what we're seeing effectively is this data, but it's like flipped. In this scenario, we have one big list with one gray heading. That's called a tree with one branch. It's basically a list, if you're familiar with coding. In this scenario, we're seeing a lot of gray things, so they're all separate lists. So it's like a list of lists. What we want to do is we want to flip. It's like a flip the matrix. I'm going to try and explain it to you better using Excel, but while that loads up, I will show you the flip matrix command. There we go. Now it's in the exact same structure as we needed from the beginning. 353 layers, layer names even. And that's the information that we've got from this list of effectively text. We've taken out all the information we don't need, leaving only the layer names. And that's it. that's our AutoCAD data from our engineer, directly from our engineer, in Grasshopper. So let me explain to you what that flip matrix thing does. Let's just say we have A, B, C. And we have 1, 2, 3. In this scenario, it's like mirroring these. Transpose, it's called. So when Grasshopper is reading this information, it's effectively reading it as list A with all of the data inside it. When it's looking at it like this, it's looking at it the other way around. So 1, 2, 3, A. It's looking at it like this. So when we flip matrix, it just keeps the A on top and the numbers to the side. Like that. That's effectively what flip matrix does. It flips the data, reads it differently. So yeah, last thing I'll confirm, 353 lines and 353 layers. Each of these corresponds to each of these. And we have our layer data from AutoCAD in Grasshopper ready to do the next step. Okay, so I'll keep that one and I'll delete these. In fact, we'll keep this final part here just so that we know, or just for fun. And then we will start working on the geometry. All I want now is the X and Y coordinates. I don't need the Z coordinates, and I'll show you why in a second. So if I select element geometry, that's what we have. I'm actually going to shrink this down because we want to use this for reference, just so that we can see things. But we don't want to use it like, we don't want it taking up the whole page. If you have multiple screens, it's much nicer, yeah? In fact, let's do this. Yeah, there we go. Right, so the first thing I need to know is where is this light going to go? So I find the midpoint, curve midpoint it's called. Double click, start typing, curve middle. So yeah, that's the one, curve middle, not curve midpoint. The output will be a midpoint. So I'm not going to keep that there, we're not really learning anything. We know that they're all lined like curves. And there we go. The X's are on the midpoints of the lines. Now if I was to place my lights down now, we would see a big problem. In fact, let's begin doing that. If I search, in fact, I'll show you where to find it here. Revit component, and we say, which one is it? Add component location. And then we say, double click here and say level picker. So now I've got all the levels to choose from. This is level 0, so I want to choose level 0. And I'll plug that level in here. We'll remove this. In fact, no, we'll keep that there so that you understand. No, we'll remove this. We know what that is. Want to keep lines minimal. So at level 0, I want to place all of these families, all these types there. In fact, before we do that, I'll show you a good practice. It's called a data dam. Right click, name that A, and then this is good because it means that once you start editing things at the back, I want to keep them in order. Once you start editing things at the back, it's not going to recompute. So all this is doing is just holding data, and when we press play, it will send it to the next node. And so now I have those midpoints as the locations. I can get the locations of those. It's a list of points, as you can see, X, Y, Z coordinates. And I just plug that in. So it will take the X, Y coordinates and place it at that level. And I hit play. And it will place all of them in those positions, but there's going to be a problem. What's happened is it's placed them at the floor of level 0. Oh, hold on a second. Let me delete everything. This is one I made earlier. So it's got the old lights there. Let me delete all of them. And let me run that script again. So, as you can see, the data dam, the moment you change anything in the back, it blocks everything from going back to adding component, and then when I hit play, it adds them in again. So yeah, as I said, it's placed them on the floor because that's the level we placed them at, but the rotations are also incorrect. Why is that? Well, we only gave it the positioning of the families. We didn't tell it what rotation we wanted. So it will by default place them at the default rotations, which is just, in this case, just flat. What we need to do now is find out the rotation away from the default positioning for each of these lines. And just to make it interesting, I want to open up this DWG and just move these lines a little bit to show a little bit of variation on angles. So, how do we do that? Well, the first thing we need to do is we need to find out what the current rotation of these is, right? And we do that with a vector. So we first find out the endpoints, so this point and this point. So now we have the data of those points. We have the start and end of each line. Yeah? So now we want to create a vector of each line. A vector is just a direction. Oh no, we don't want that. We double click and we search for vector 2 points. There we go. It will give you a 2-point vector. So the starting point is point A, so every single line's this point here that I'm hovering over will go into that, and then when we feed in the end point to point B, we'll take every single one of those and put those into vector B. So if I've given it this point and this point, it can create a vector, a directional vector. Yeah. There we go. We can even get the lengths if we wanted. We can see they all vary. So, with that in mind, let's open L0 as I was doing earlier. So take a quick break on thinking about that. I'm just going to rotate this slightly, and I'm going to rotate that slightly, just for argument's sake. In fact, we'll rotate them both, yeah, and hit save. Minimize. And then come to Revit. And then we will go to Manage Links, CAD Formats, L0, Reload, and we're going to be looking over here. There we go. So now, when we run our script again, what's going on here? Hit play. You can see that they've moved accordingly. Yeah? Rotation's still a problem. Okay. So, all we've done is we've found the direction of each line. So we've given that data to Grasshopper. We haven't done anything else. So don't worry if you're confused. So we've got curve midpoints here, and separate to that, we've got curve endpoints, and then we found the direction of all of those curves. I know they're lines, but they're called curves inside Grasshopper, if you're confused about that. Let's make this a little bit more tidy. Double click the line to get this thing here, and we can keep it nice and straight. So, what do we need to do now? See, when Revit, or when Grasshopper places things down inside Revit, it finds the original point, the base point. And when we tell it we want to place it at the midpoints of all of these lines, it finds out where those points are relative to this central point, and it just places them there at that, relative to the origin point, basically. So what we can do is we can construct an origin point just inside Grasshopper for every single one of these. We can tell it where it is, and we can give that origin point a rotation. And once we do that, we can tell it to place families there, and it will rotate them by default into something aligned to the origin place. I really hope that's a good explanation. I don't think it is, but it's a very hard, difficult thing to explain without diagrams. I could have maybe drawn a diagram, but yeah, I didn't have time today, to be honest. So let's do that. Let's first put the origin plane down, the plane. So we double click and we search for construct plane, and we want to tell it that the x-axis of our plane is going to be the vector of each line. So what it's going to do is it's going to create a plane with each line, a start point and end point, as its default x-axis. Now, to tell it where the origins of each of these are, we feed it our midpoint. Now, the y-axis is this vector flipped by 90 degrees. So we will rotate that by 90 degrees. So to do that, we get the rotate node, and we need the plane, which will be the default XY plane. Is that by default? Yeah. So you can actually type XY plane and plug that in there. but because it's set to XY by default, I'll just keep it blank, right? Because I like to keep things nice and tidy, and someone coming in can easily see that the plane is missing if they wanted to do it on a different plane. In this scenario, we would never need to do that, which is why I'm not going to put it in. But in my original image, you'll see that the XY script was in the, sorry, the XY plane was in there in this particular bit. So now what I will do is I will plug in an angle of 90 degrees. I'll just copy one of these. Now this angle thing takes an input as in radians even. So I need to convert from degrees to radians. Just type radians and you'll get this. Angle. Brilliant. So what geometry am I rotating by 90 degrees? It's the vector itself. Yeah, I'm taking all of those vectors, rotating them by 90 degrees. And then I'm going to plug that into my y-axes, because my x-axes are the original vector, 90 degrees, so that is my y-axis. In fact, hold on a second. What's it by default? Doesn't matter. And that's it. Now we have, this is one thing we can't really see. Oh, we can actually. There we go. We can see the plane. If we zoom right in, and then if we zoom in here, we see the plane is rotated to match the line, those ones we rotated. Brilliant. Oh, that's a really good way of showing that diagrammatically. So now, whatever we put on those planes will be aligned to the plane. That's how it works in Grasshopper. We don't need to know about why exactly. All we need to know is that when you put it onto any plane, it by default puts it on its default 90-degree rotation to the, its default rotation relative to the plane. So if you shift the plane, rotate the plane even, the whole thing will rotate with it, the whole element. And instead of our curve midpoint going in here, as we had earlier, we're going to now stick the plane in there. So Grasshopper will take its coordinates and use the coordinates of the plane for the location, and by default will take its rotation. So if we hit play, we now have those lights all aligned to the lines. Ain't that fantastic? And so as we looked at earlier, if we were to undo our rotations and save, so imagine in this scenario we're editing, we say manage links, CAD formats, just reload all of them. It will only reload the ones that change, and there we see that. And then if we come to Grasshopper, let's just shift this down a bit so we can see it live. We'll look at it. It's these two and these two, and we hit play. It will now read the new file, place them accordingly. We could even, without even changing the size of these, change them to L04s, save, and then sorry. It's hard to do with just one screen, but I need to only use one screen so you guys can see. So you guys are slowing me down, but it's for your benefit anyway. So please hit like and subscribe. Reload, say okay. Then we hit play, and there you go. It's changed the size. And we didn't even need to resize this. We can even set it to resize these lines based on the length of the lines, which is for another video. But let's keep that at L03. just to show you how fast it can be when you're all set up. Reload, say OK, plug that in there, and there we go. Cool, 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 cool. Now, last thing, we need, obviously lights can't be on the floor. We need to tell it what elevation those need to be at. There could be, no, hold on, sorry. Yeah, inside of this light family, I believe there's a parameter called elevation from level. Usually with light families, they have those. And with mine, there is. So, in fact, we don't even need this anymore. We know what we're doing. We don't need. We don't need the Rhino window. We can just use the Grasshopper window because we don't need to figure out what geometry we're looking at. When we select this node, we know what we're selecting exactly. Anyway, so if we come down to element and search for inspect element, plug that in there, and then hold shift and double click inspect element, we find all of the parameters for those lights. These are all the common parameters. We're going to be using elevation from level, but before we do that, I want to show you something else. Come to element and we say element type. Plug that in there. We can actually see the type parameters. So that's for for each component. So if we were to look at each one, let's just say the length, we would find the lengths all differ, and let's just say the widths are all the same because they're the same light from cross section. If you wanted to know the element name, we could search for element name, which is in the same. There we go there. In fact, we can go straight from component. There we go. So that's the element name. The element itself is this, and just its name is this. So we don't need to chop anything down if we want to know the name of it. So now, because I'm going to do element itself, right? So we can actually just go directly. These are instance parameters. So each instance can be at a different elevation, right? So the constraint of elevation from level is an instance parameter. To those that don't know, oh, why did I delete that? To those that don't know what that means, these are parameters. If we edit type, you change this, it will change them on all of them. Whereas if you select this one, you can edit specific parameters that are only for this one. Yeah, so this way you can have a light that's at 900 or 3000 millimeters high, and then different ones at different heights, as you can do in real life. But that specific light will be a specific size. In that scenario, you'd want those parameters of the sizes and things to be editable for all of them. Now, instance parameters, we only want elevation from level. And we want to edit that parameter for all of these things. So, let's do that. What I like to do is I like to plug the one I want to work with, and I like to close this down and say hide unconnected parameters by right clicking. That's the only one I'm going to need. So we'll delete this as well, we don't need that. All I've got is the node, placing them down, and the elevation from level parameter that we need to change. And I say element parameter oh no, what? So I take the element, plug it into element. I take the parameter, plug it into parameter. So now it knows that I want to either just take a look at the values, current values, or what elements there are. But what I also want to do before I take a look at my masterful list of work, or my masterful work in list format, is I want to change the values themselves. So right now I'm using this as a viewer, but I can also use this as a setter. That's not a real word, but I can use it to set the values, is what I mean. So in this scenario, I'll just stick a number slider in there, plug that in, and there you go. I can change the height live. You wouldn't really want a number slider in this scenario. I would just say be sensible. Just copy one of these down, because in real life you're just going to type a number in. The number slider is nice and cool to show off nice videos and all that, but once you know that it's going to be a straight up rigid number, you just want to put that number in there and type it in, because you're never going to slide into that position, are you? And there we go. If you want to change it now, you say 2,500. They're all hanging at 2,500 now. And we could look into further detail to change the heights of each one in each region. We can do that. We can do so many things with this. We could even place at level 1 instead. And it will copy the height data. There we go. So I hope that's been a good video. Next I'm going to show you how to do it for each level. So now the thing is this. If my intention was to do this for every level, if I change this to that floor, and then I run it, so the basement level, it's got rid of my old lights, because these are all tracked. We can change the tracking mode, but we don't want to do that for this scenario. It's less effective that way. How do I do this for all floors at once? Now, it can be done in one script, but we're not going to do it that way, and I'll tell you why. Because it makes the data structure a lot more complicated, so it's more difficult to deal with, especially when you've got more junior members of staff who need to work with this. But the other thing is, it's actually more beneficial to have a separate file for each DWG file, because we can just run the specific Grasshopper file that we need. So what I've done is, I file and I save document, and then let's just go to, where is it? Lighting script. Final Grasshopper scripts and lighting placement, maybe you could name it. And I've got one for each floor. And then I'll just say B1X, right? Just to make it differentiate. And then, obviously it's for L0, but you know what I mean. And then I'll say File, Save Document As, and then maybe L0 or whatever, yeah? And then rename this to L0 and go in, and then remember to change the level to level 0, and remember to change the DWG to level 0. Now we have two separate files. Oh, okay, sorry. Before we do that, we need to understand that this node was made in the previous file and is associated to all of the elements from the previous file. What you want to do is you want to copy it and paste it, which may take some time depending on your computer. And you want to delete the old one. And then, yes, I want to delete all. And then I'll plug that in there, and I'll plug that in there. And so do that. Good. Now this is associated to that level. I'll save this, and then I'll open the new one, the old one, B1X, and we see it's associated back to those original ones, yeah, because it was saved when it was associated to those lights. So well, you know what I'd say? I would say when you want to make new ones, you can delete this completely. No, actually, you don't want to do that. Figure out your own way, because this part is a little bit annoying, but at the same time, I understand why it is the way it is. Find out your own way. It's not that big of a deal to make one for each floor, and then once we're at that stage, we can save this. We can close it down, and let's just delete all of those lights. In fact, no, let's not do that. Let's keep only the lights. And let's go to Civil 3D. Let's delete a bunch of these. And change a bunch of these to smaller ones. And hit save. Let's keep only that floor so that we know, we can see what we're doing. And then I'll say manage links, CAD format, reload all of them. Say okay. We can see that, you know what, let's keep the CAD file as well. We can see that we've got lights missing, but we've got lights there. So nothing's happened yet. And instead of having to launch Grasshopper every single time, I can come to Rhino inside and I can say Grasshopper player and B1X. No, sorry, it's L0X. There we go. That's our lights done. Without even having to open Grasshopper, without having to read a single PDF or DWG or whatever. And just to show you how easy it is, because when I'm doing things it can look like it's quite long, we can go all the way back to original, save, manage links, CAD formats, blah blah blah, reload, say okay, and then Rhino inside, Grasshopper player, L0X. Brilliant, brilliant, super fast, very good. And there's my whole structure. And then we can do it for all the other floors. So it's a very good tool. Feel free to download it from the link provided. And if you want to learn this, if you like this video, please hit like and subscribe and all that good stuff. And if you have questions, email me or message the comments below, and I'll get back to you. So see you on the next one.